In this lesson, we're going to talk about various reasons why you might want to use surface modeling in SOLIDWORKS. Surface modeling has three general purposes. The first purpose is to create models like this, where you cannot create any of the faces using your typical solid features. Solid features like extrude and revolve create enough faces to enclose a volume all in one step, while surface features such as extruded surface or boundary surface or fill surface only create one face at a time. Let's roll back and have a look at this. Sometimes surface features are used for reference, such as the first two surface features in this part. And then, sometimes, surface features are used for actual part geometry, such as this boundary surface. So creating a model face by face is one of the tasks that's commonly assigned to surface modeling. And that's done because solid modeling has to create features with multiple faces in a single step. So that's the first purpose for learning surfacing in SOLIDWORKS. Another purpose is for dealing with imported data. Solid geometry in SOLIDWORKS is really just surface geometry that follows special rules. So you can move in and out of solid and surface geometry several times depending on your needs. For example, we take a look at this part, and we imagine that this were all an imported part. So let's take all of the features used to create this and put them in one big folder. So this might as well be an imported part. Let's suppress these last two features because these are the ones I used to fix the part. You might want to remove one of these ribs, and there are two ways that you might do that. One is the rather clumsy way of trying to find solid features that you could extrude in order to remove all of the faces of this particular feature. That might work, but an easier way to do it would be to use surfacing techniques, such as the delete face. Using delete face, you can select all of the faces around the feature, and then just remove these faces from the model. When the faces are removed from the model, it leaves a gap, and let's see what happens. Okay, we've got a hole in the model. Notice that the model changed from a solid body to a surface body. We can now take this hole in the model and delete the hole just by pressing delete on the keyboard and say OK. SOLIDWORKS has patched up that hole, but we still have a surface body. We can force that surface body to become solid again by going to Insert, Boss Base, Thicken, select the body, and select the option to create a solid from enclosed volume. Now you can see this is switched back to a solid body. So a solid body is really just a surface body that follows special rules. And those rules are that it encloses a volume and that the faces have no gaps or overlaps. So using this basic concept and the available tools in SOLIDWORKS, you can move easily back and forth between the solids and surfaces worlds. The third use for surfaces in SOLIDWORKS is for parts like this. Sometimes you need to create reference geometry, even in machined parts or parts for machine design. If we take a look at the first use of a surface feature in this part, we have an extruded surface, and this just acts as a backstop for a cut feature. So let's take a section that goes through the part. Roll it back. Here's our surface that's extruded, and we've created a cut that goes up to that surface. Something like this would be difficult to do without that surface feature. The next use of a surface in this particular part was to round the edges. And if we take a look at this, we'll just show it here. We can hide the solid body, And what we've done is created a sweep that goes around the part that has incomplete fillets at the top and the bottom. So let's show the solid body again. And from here, the surface was used to cut the solid. This could have been done with solids, but it would have been much more awkward. So these are the three general uses for surface modeling that you will find in SOLIDWORKS: creating a model face by face, deconstructing imported geometry and making repairs, and finally, as reference geometry.